In this video, I wanted to review the differences between solving an equation and an inequality, and review the different ways that we write our solution. Because in a lot of different chapters in the book, sometimes we're going to express solutions to things like domain and range in the form of an interval. And there's various different ways that we can describe these sets. But starting with inequalities in general, inequalities aren't so much different from an equation. I mean, the only difference is that instead of having one side being equal to another, we have one side either being less than the other or greater than the other, or less than or equal or greater than or equal to, which just implies that it could be both greater than or equal or not. And what's nice about inequalities is there's very, very few differences between solving an equation and an inequality. Like an inequality such as this one, x minus 7 is less than or equal to minus 15, the underlying goal is still the same. The goal is to figure out, well, what's the answer? But the difference with, in an equation is typically there's one answer. Again, it can depend on the type of equation, but that's usually how it will work. But within an inequality, there are typically lots and lots of different solutions in the form of an entire range. But we still can use the properties of equality in an equation, because in our primary equation, x minus 7 less than minus 15, it's kind of saying that, well, this side is less than this side. If we were to say add 7 to both sides, the inequality will still remain true. So we're not changing the logic behind the inequality if we were to add 7 to both sides. And again, in that way, we could hone in on what x must be if we were to isolate x. So the primary goal is still kind of the same. Put all the variables on one side, put all the numbers on the other to try to find the answer. So, if we were to add 7 to both sides here, right, that would leave us with, well, x, and this would turn to 0, is less than negative 8. And this would be as far as we could go in terms of simplifying our answer. And that would be, for some reason, the equal sign came out a little weird looking. Or sorry, the negative sign, came out looking like an equal sign on my tablet for some reason. But from there, well, another curveball to solving an inequality is, really, we did solve it. We know that all values that solve this inequality are the values of x where x is less than negative 8. And also remember, with negatives, numbers which are smaller actually have a larger absolute value, like negative 9, negative 10 would work here. But for example, negative 6 is not smaller than negative 8, because negatives always work backwards. But what I wanted to review is typically how do we write our answer? Because technically this is fine, but usually when in math we're trying to write it as a set rather than as a simplified inequality. It's kind of like if we're solving an equation and we get the answer x is equal to 11, that's fine and all, but sometimes we might want to write it as a set, where the only difference would be if we could say x is an element of the set of numbers 11 using a set notation, and all this would indicate is that it has one singular answer, just 11. And it's kind of like splitting hairs in terms of, well, how should I answer it? It doesn't really necessarily matter. But a lot of times with sets of numbers, we don't want to write them just as an inequality, but instead as a set. So there's a few things we can do here. The first is to graph our set of solutions on a number line. And this is a common, way of answering it, to try to visualize what this means. But if you recall, we could draw a number line just as a line such as this. Usually we try to reference to where 0 is. But if I'm trying to graph this inequality, I would start at the number that I have, because this is the boundary line between it being true and false, right? All the answers to the inequality are where x is less than negative 8. And so when it's at negative 8, which would be to the left, and you could mark individual tick marks on this line, but sometimes it's okay to just, reference it as minus 8 and not have to actually draw the little lines in there. But if you recall, we either draw an open circle, or some books will actually draw parentheses on the number line. I'll go ahead and do it both ways just to sort of emphasize the difference, because it depends on which book you're reading. But I tend to use the open circle because that's how I remember learning it whenever I first learned this stuff, and I think it's a more common notation. But basically, if we want to, what we're going to do is we're going to shade all the numbers that are a part of our answer. And since, the acceptable set of answers here is the values of x that are less than negative 8, all values less than negative 8 are to the left, right? Because it goes from small to large on the number line, where, to get smaller than -8, we get like -9, -10, etc. And that would be what we call a graph of our set of numbers, or our solution to the inequality. And so the other way that I was mentioning is sometimes people will use a parentheses and shade it this way instead. This is just another way I've seen people do it. So this, either way is fine. You can draw it either way if you want on your, class activity, or, but, when you're looking for the online homework, I believe they're going to use this sort of graph for our textbook. I can't remember off the top of my head right now which our specific book uses, but I'm pretty sure it uses the open circle. And the only difference is if it were an inequality such as less than or equal to, is that would include -8 as being a part of our answer. And so we would shade in -8 as a closed circle, or how we'd write that on a number line would actually be using a bracket instead. The bracket indicates inclusion because it's a little bit more, it kind of has more stuff in it, whereas the parenthesis means it's not part of it. And that's the difference between an open and a closed circle. But in this case, I don't want that because I'm not changing it. I'm just saying, well, what's the only, that would be the only difference between an inequality which includes equality and one that does not include equality in its initial form. So the other ways we write it are using actually set notation. Since this is not a set notation, it's a visualization, kind of like when we're graphing an equation or something. It's not necessarily the equation, it's just one representation. But basically, interval notation is another very commonly used notation, which is a way of describing this interval of numbers, which, again, the shading is a way to help us think about it so we can imagine what numbers are in that set, but using intervals. And how we'd write this answer using interval notation would be parentheses -infinity, comma, -8, parenthesis. And basically how interval notation works, I'm assuming a lot of you guys have seen this and remember it, but I'm just going over the basic details because we're going to be using it fairly often, and it's worth recapping. It's a way of writing the graph of an interval using a dual input bracket parentheses statement. So it looks very much like an ordered pair, like 3, 4, when we're graphing a point in the coordinate system. But it doesn't have the same meaning. It has a meaning of, well, what are my numbers from left to right? What is included in my interval? And since really all numbers less than -8, there's no end to this, right? Because there's an infinite number of numbers which are less than -8, -10, -100, -1,000,000, -5,642,000, whatever, So that's a lot of different numbers that are answers to this inequality. And basically, from my graph, I can tell, well, it's everything smaller than -8. And since there is no boundary, we often say that it goes to -infinity, meaning that infinity is not a number, it's not an endpoint to an interval. It's just the idea of, well, if there was a smallest number, what would it be? And same with going to the right, we would just call that positive infinity instead of negative infinity, because there is no such thing as the largest number. And infinity is not attainable. It's not, number, but it's an idea which is expressing that limitlessness of an interval. And that's exactly what this interval is. So if we read, well, what is in our interval of numbers from left to right? It's everything between -infinity and -8. And the parentheses indicate that -8 is not included in this interval, kind of like when we put a parentheses on it like this. But as I said, if we were to use a bracket up here, we would use a bracket down here and a solid circle like that. That would indicate when x is less than or equal to -8, and it would include that boundary point on the interval. But in this case, we're using parentheses on both sides, which indicates that -infinity is not included. And I know I shaded it in to the left, but like as I said, infinity, you can't ever reach it, which is why we don't typically put a bracket on it. Now, it's actually interesting because some books will include a bracket on infinity. Most do not. So actually, you can do it either way. There's not like, it doesn't really matter which one you put on infinity. But it is important that you use a parenthesis on -8, or you know, a simpler way to remember it is when there is no equal sign on it, use a parenthesis on that number. When there is an equal sign, use a bracket instead. And we'll do a few more examples in the next video. And again, just to recap what this means, when I write it in interval notation, all this means is the interval of numbers I'm trying to describe with this notation is everything between -infinity and -8, not inclusives. So I can kind of imagine that, well, really that's everything from the smallest possible number until -8. So, you know, this just means the same thing as this. Everything smaller than -8 with no limit upon that. And the last way we might often write it is with set, what some people call set builder notation, or just set notation, which is basically just taking the inequality and translating it to a mathematical set. So if I write it like this, x is the set of numbers such that x is less than or equal to -8. This would be how we would write it using set notation. And sorry, I'm not showing my work in the same place as my bullet points from my slides. So I'll just draw those arrows to sort of show you where my answers go to. But that being said, so what does this mean? Basically, what I'm doing is I'm putting my algebraic inequality into a set notation. So when I write it this way, what this says is, well, this is the set symbol. We're using the mathematical brace, which is like the little squiggly parenthesis thing. And basically it's saying the set of numbers x. So that's kind of saying, well, it's a set of unknown numbers, or a set of numbers that we're just going to call x for the purposes of this set. Where we have the singular line, which is called the such that line. Basically we're saying all the values of x such that they obey this inequality, which is exactly what we had before. So really this is just a set way of writing the solutions to this inequality, but basically we're just putting it into a set. And for now, it's really not that important, but in higher level math, set notation is used quite a bit more frequently to describe different sets of numbers. And there's a lot of notational things you can do to convey your meaning, but at the end of the day, it's just another way of writing a set. And again, sometimes the homework or the packets might use one form or the other. I think it's important to recognize all the different ways we write the solution to an inequality. Now in the next video, we'll actually do some more practice solving, because this one was very, very rudimentary. We'll do a few more, and there are a couple differences that we'll recap between solving an equation and an inequality in the next one.